In today's lesson, we'll be learning how to complete the square. Completing the square is a process which transforms a quadratic relation in standard form into a quadratic relation in vertex form. Completing the square involves creating a perfect square trinomial, which is then changed back into a binomial which has been squared. In our first example, we want to convert our quadratic relation, which is in standard form, into vertex form. Let's begin by rewriting the question. We're going to take a close look at the terms that contain x. You want to do group factoring. You need to ask yourself, is there anything that I can factor out of x squared and positive 8x? However, you can only factor out a number in this step. I do not want you to factor out a variable. Therefore, you should come to the conclusion that the only thing you can factor out is positive 1, and that doesn't do anything to x squared or positive 8x. So I'm just going to leave it as is, and I'm going to put them in brackets. In the next step, you want to identify the coefficient of x. The coefficient is positive 8. This is what you're going to do with positive 8. You're going to take positive 8, you're going to divide it by 2, and then you're going to square it. Okay? So positive 8 divided by 2 is positive 4, and positive 4 squared is positive 16. Now, you don't need these plus signs. However, I'm just putting them in to emphasize that the sign is important. We're going to take this positive 16 and we're going to add it within the brackets. However, we must also subtract it. Because positive 16 subtract 16 is basically 0, which means we haven't done anything to really change our equation. At this point, you want to take a look at the negative 16 and we want to move it outside of the brackets. Now, if there was a coefficient in front of the brackets, you would have to multiply negative 16 by that coefficient before moving it outside of the brackets. However, in this situation, it is positive 1, so it doesn't change anything. So in this step, everything stays the same, and the only thing I'm doing is I'm moving that negative 16 to outside of the brackets. All right, now at this point, we can just simplify some of these numbers. Everything else stays the same. Negative 16 plus 5 is negative 11. At this point, you should have noticed that we've created a perfect square trinomial. So you need to ask yourself, what are two numbers when added up give you positive 8? And two numbers when multiplied together gives you positive 16. That should be pretty easy. That number is positive 4. So I'm going to factor this perfect square trinomial, and it's going to factor into x plus 4 multiplied by x plus 4. The negative 11 stays exactly the same. And when you have something multiplied by itself, you can simplify that by using exponents. So this would be x plus 4 squared minus 11. And therefore, you now have the quadratic relation in vertex form. In our second example, we want to convert our quadratic relation, which is in standard form, into vertex form. And we're going to do that by completing the square. First off, let's rewrite the question. I want to closely analyze the terms which contain x. You want to group factor these two terms. However, you do not want to factor out a variable. You only want to factor out a number, so the greatest common factor. The greatest common factor of 2 and 12 happens to be 2. Therefore, I'm going to factor out a 2, which leaves me x squared plus 6x, and the plus 11 stays exactly the same since I'm group factoring. At this point, you want to identify the coefficient of the term which contains x. And the coefficient of the term that contains x is positive 6. What you're going to do is you're going to take that positive 6, you're going to divide it by 2, and then you're going to square it. So positive 6 divided by 2 is positive 3, and positive 3 squared is positive 9. We're going to add in this 9 as well as subtract it. And we're going to do that within the brackets. Plus 9, subtract 9, then plus 11. Remember, positive 9 subtract 9 is equal to 0, so we haven't really changed the equation. We want to take a close look at this negative 9. We want to move it outside of the brackets. However, when you move it outside the brackets, you have to remember to multiply it by the coefficient of the brackets, okay? So I'm going to show you what I mean. So everything else stays the same. However, when I'm moving the negative 9 outside of the brackets, I have to remember to multiply it by positive 2. So negative 9 multiplied by positive 2 is negative 18. And the plus 11 stays exactly the same. At this point, you want to simplify some of these numbers. So negative 18 plus 11 is negative 7. And what you have left inside the brackets is a perfect square trinomial. So you need to ask yourself, what are two numbers when added together gives me positive 6, and two numbers when multiplied together gives me positive 9? That should be fairly straightforward, and that is positive 3 and positive 3. Which means we can factor our perfect square trinomial into x plus 3 multiplied by x plus 3, and the negative 7 stays the same. However, when you have a number multiplying by itself, you can simplify that with exponents. So that would be x plus 3 squared subtract 7. And there you have the quadratic relation in vertex form. In our last example, we want to convert our quadratic relation in standard form into vertex form. The first thing you want to do is rewrite the question. So I have y equals negative x squared plus 2x plus 3. You want to closely analyze the terms which contain x. We're going to do some group factoring here. However, I do not want to factor out a variable. I only want to factor out a number. Out of the two terms that I underlined, you can factor out a negative 1. So I'm going to do that. Now, you do not need to write the 1. You can just leave it as a negative sign. However, I am leaving it as negative 1. At this point, you want to identify the coefficient of the term which contains x, and that is negative 2. So I'm going to take negative 2, I'm going to divide it by 2, and I'm going to square it. So negative 2 divided by 2 is negative 1, and negative 1 squared is just positive 1. So I'm going to add 1 and subtract 1 from the brackets. Because positive 1 subtract 1 is basically 0, and if it's 0, that means we haven't really changed the equation. At this point, you want to take a close look at negative 1. You want to move it outside of the brackets. However, when you move it outside of the brackets, you have to remember to multiply by the coefficient of the brackets. And the coefficient here is -1. Which means we're going to have to multiply -1 by -1 before it can exit the brackets. So -1 multiplied by -1 is +1. And the +3 stays exactly the same. At this point, you can just simplify some of these numbers. So +1 plus 3 is just +4. At this point, you should notice that you have a perfect square trinomial. And we want to factor this. So you need to ask yourself, what are two numbers when added together gives you -2, and two numbers when multiplied together gives you +1? And that should be pretty straightforward. Those two numbers are -1 and -1. Therefore, when you factor this perfect square trinomial, that is going to factor into x minus 1 multiplied by x minus 1. The +4 stays exactly the same. Remember, when you are multiplying something by itself, you can simplify that with exponents, and that should be equal to x minus 1 squared plus 4. And last but not least, I am going to remove the 1. So I'm just left with -x minus 1 squared plus 4. And there you have a quadratic relation which has been converted to vertex form from standard form.